All right, teachers, welcome to the brief overview you guys are going to get prior to running through this lesson with your students. Please make sure that you are following along, you're watching what's happening, and you are creating your notes with which you can teach. Now, a couple of quick things that I want to review since we haven't done this since the end of December, or I guess middle of December. When you're doing this, make sure that you are not providing your students with the answers. You are pushing them to get to where they need to be through guiding questions and not necessarily just spoon feeding them the answers. Also, please remember, if all of your students end up passing the mastery check with a 70% or higher, then you are getting the 150% on your mastery check. Otherwise, you will be getting the average of your students. So, going through the independent investigation, today we will be looking at one of three methods to solve a system of equations. That method is called graphing. Marianne and Carlos are each saving for new scooters. So far, Marianne has $9 saved and can earn $6 per hour babysitting. Carlos has saved, or has $3 saved, and can earn $9 per hour working at his family's restaurant. So, I'm going to take a moment, pause, and have you run through that. So please pause the video here and try step one on your own. Write an equation using that information for Marianne and for Carlos. So hopefully you were able to do that. One thing I really want to stress, especially when we are doing systems of equations, are really underlining and circling information that you need in the text. If you're not doing this, if you're not funking the text, if you're not really digging into what the text is telling you, it's going to be really tough. Now, in this case, it's not super difficult for the simple fact that it's a pretty simple word problem. But later on, if you're not doing these things, you're going to be running into more trouble. So in red, we're going to be talking about our initial values. So I see that Marianne has $9 saved. Carlos has $3 saved. Now, the reason I know these are my initial values are because that's what they've currently saved. And I know that my rate of change in these, let's do this in blue, I can identify pretty quickly by seeing that per hour tacked onto the number. I know that per hour means that this is going to be the coefficient. It's going to change based on the number of hours that they're working. So let's write these equations. Equation for Marianne. Hopefully you were able to come up with y is equal to, or the cost is equal to, $9 that she has saved in addition to $6 per hour. So in order to make sure this is in a nice, pretty slope-intercept form, I'm going to say 6x for $6 per hour plus the 9 that she initially has. And then I go to Carlos. And I say, well, Carlos, the amount he has saved is equal to the 3 that he currently has saved and $9 per hour. So the 9 is my coefficient of x plus 3 that he has saved already, my initial value. Now, I'm sure some of you, especially in this class, are a little upset at me because I didn't do the number one thing that I've always told you to do every single time, which is create a let statement. But I've already made one for you right here, and I've put the note here. You can run your students through that. Note that I've provided you a let statement. You must always have a let statement. If you don't have your let statement, you don't know what you're solving for, and it becomes decidedly more difficult. Now, I've created these two equations. And I want to present these as a system. So I'm going to actually write this system over here by putting a bracket. Let me zoom in on this a little bit. A bracket wherein we have, let's make this, we'll do the red line. We'll do the blue line. Now this isn't necessarily something you have to do, differentiating the lines based on color. I'm doing it so that you can visualize it, so that you can better teach it. I would recommend when you're teaching it, using colors as well. Now, we know that Marianne earned money at, or in a way that can be represented by y equals 6x plus 9, y equals 6x plus 9, and Carlos earned money in a way that can be represented by y equals 9x plus 3. So now that I've got that written down, I'm going to go to my step 2. Step 2. Graph each of these equations. What is the point of intersection? What is the point of intersection? We're going to find out what that means in a little bit, but let's start off. Let me use a slightly bolder pen here. Well, hopefully you remember how to graph things. I know that my y-intercept in this case is 9 for my red line, so I'm going to put a dot at 9, and I see that the slope is 6x. I see that my x values here are going up by 1s, and my y values are going up by 6s, or by 3s, I'm sorry, I can speak. So if it's going up by 6, it's going to go up 6 over 1, up 6 over 1, 6 over 1. And this is my line for Marianne. We're going to call this line, let's just call it Marianne. So that's my line for Marianne. Now let's put our line for Carlos, which we see we've done in blue. Y equals 9x plus 3. Well, plus 3, so I'm starting at a point of 3, and I'm going up by 9. So I go 3, 6, 9 over by 1. 3, 6, 9 over by 1. Oh, that's interesting. 3, 6, 9 over by 1. And I connect these points. Now again, I want to go back to what I'm looking for, and again, I've underlined, I'll even circle it. What is the point of intersection? Well, the point of intersection in this case is 2, 21, because remember x comes before y. 2, 21. So, write it as an ordered pair, we're good there. Let's go to step 3 where it says check your answer, substitute the x coordinate of the point of intersection into both equations to verify your calculations. Well, let's try that. In red, just to keep some consistency, I'd have is 21, question mark, is 21 equal to 6 times 2 plus 9. Well, is 21 equal to 12 plus 9? Yes, in fact, 21 is equal to 21. So the Marianne line was satisfied. Oh, I just realized I did terrible there. We didn't label our other line, Carlos. The Marianne line is satisfied by this ordered pair. Now, let's try the Carlos line. Well, the Carlos line would say, is 21 equal to, is, question mark, equal to 9 times 2 plus 3. Well, hopefully you can see pretty quickly, 18 plus 3. They are, in fact, both satisfied by this coordinate pair. So, coordinate pair 221 satisfies both given equations. And hopefully you've seen that this is a very simple and somewhat rudimentary, but very simple way of solving a system of equations, determining the point of intersection when you graph both of them. Now, what does this represent in context, right, in complete sentences? Well, anything that you end up putting in here to the effect of, let's find out what these mean. My y value is the amount saved, and my x value is the hours worked. So an appropriate answer could have been something to the effect of Carlos and Marianne. I can type. Thanks, Alondra. Carlos and Marianne would both have saved $21 after working for 2 hours. That's what it represents in context. And again, something I really want to drive home is this term in context. You're going to see this a lot, and this is something that I really want you to focus on with your students. In context means in the situation presented in the problem. So here it wouldn't make any sense for me to say, oh, well, you know, in the situation of Carlos and Marianne, after, 2 miles, it took them 21 minutes to walk 2 miles or something along those lines. That's not what this problem is talking about. Therefore, it has nothing to do with the context of this problem. So hopefully that took you through. What I want you to do really quickly is go down and try to graph both of the equations in the U-try. Take a moment, pause the video, and do that. All right, so coming back, let's label our lines. Again, you don't have to do this, but it's good practice so that you can make sure that your students fully understand what you're doing. Let's graph some lines. So my blue line is x plus 5. Well, plus 5 means that it's starting here, and the slope of x means it's 1x, which means it's up 1 over 1. And if I want to graph backwards, I go down 1, back 1. There we go. That is a very poorly drawn version of that line. Now, in red, we're going to say, well, it starts at -1 with a slope of -2. So down 2 over 1, down 2 over 1. And if I'm going backwards, I'd go up 2, back 1, up 2, back 1, up 2, back 1. And hopefully you can see very quickly what I've just highlighted in yellow is the solution. Took me a long time to say that. Is the solution to this system of equations, which in this case, the solution is -2, 3. -2, 3. Where it says check, this is what you're going to run through with your students. Check means check this algebraically and see if it makes sense. So for example, if I take my y value and then put it into my y's, and my x value and put it into the x's, it should end up equaling. So for example, is 3 equal to -2 times -2 minus 1? Well, -2 times -2 is 4, minus 1 is 3. So it satisfies that equation. Let's check the second one. Is 3 equal to -2 plus 5? Well, yes, 3 is equal to -2 plus 5. So it satisfies it. It satisfies it. And again, you can continue from there. What I want you to do with the next few minutes is go in and make sure that you fully understand what you are teaching. If you have any questions, please feel free to raise your hand and I'll come over and help you. And prepare yourself. What you will be running through with your students is the investigation, the U-try, and the group practice. You will not be doing the independent practice. Please do not start independent practice with them. Again, ensure these key points are covered with your students. Systems of equations can have one, no, or infinite solutions. When graphed, systems of equations with one solution will intersect at one unique coordinate. That means there's only one place those lines are going to meet. As you've seen, none of those lines are meeting anywhere else. This coordinate gives the solution based on the two given variables, x and y. Solving a system by graphing is a simple but very time-consuming way of solving a system of inequalities. And caveat. Caveat means warning. Just make sure your students understand there are flaws with solving by graphing. If the system doesn't have whole number solutions, meaning if the system doesn't intersect directly on one of these corners, this is not an effective way of solving. Just make sure your students know that. Great. Best of luck. If you have any questions, please let me know and have fun.